All right, if you're in Ivy Tech's Math 123 course, you might want to use your formula sheet for the PV and PMT functions from Excel. But no matter what, if you have Excel near you, you might be able to hit pause on the videos and go back and forth with Excel to try these formulas out and see what it gives you, because it really makes a difference. So one thing to first think about is monthly rates, right? When we buy a house or a car or whatever, you do things in terms of monthly rates. But everything is given to you in terms of APR. Well, APR is annual percentage rate. So recall that you first want to take your APR and then divide it by 12. So your monthly rate is calculated by dividing your APR by 12. How do you calculate the number of payments? Well, there are always 12 months in a year. So because there's always 12 months in a year, right? That doesn't change. Well, you got to answer the question, how many years am I going to have this thing? So we'll take 12 months in a year, and we're going to multiply by the number of years in the, I'm going to call it a loan, but this also works for investments and things. How long are you doing it? So if I'm going to buy a house for 30 years, I would calculate the number of payments by 12 times 30, 12 months in a year, and I'm going to do that for 30 years. So the second part is the number of years in whatever it is you're doing. Number 3, what does PMT stands for? Well, one thing to remember, math people are not creative. PMT stands for payment. You use it when you are trying to find monthly payment amount. So if you're like, wow, I like that $400,000 house, how much will my payments be? You're going to use the payment function. Anytime you ask the question, how much would my payment be? You're using the PMT function. PV stands for present value. This is used when you know your monthly payment. So you know your payment. You want to find how much you can afford. So you do your budget and you're like, you know what, I can afford a house payment of $602. Great. If you can pay $602 and you know your interest rate and some other pieces, you can plug it into the formula and say, oh, look, I can afford a $300,000 house, right? You find the present value of the item you're trying to buy based off of the monthly payment that you know you can afford. All right, let's do some problems. Beth and Joe are expecting a baby, decided their house is too small for their expanding family, They find a new home listed at $118,000. Their bank has pre-approved them for a 30-year mortgage. All right, so 30 years. Mortgage at 3.75%. So I'm going to go ahead and change that to a decimal because that's how my brain is functioned. Okay, now here's the thing. They need a 15% down payment. What will you enter into Excel? Well, in Excel, we find the amount that they need to borrow. Okay, well, here's the deal. If they're buying a house for $118,000, they have to have 15% down. So what is 15% of $118,000? So when I multiply these together, their down payment is $17,700, right? This is the down payment. So how much are they going to borrow? Well, the house is $118,000. They're going to put $17,700 down, which means they are going to borrow $100,300. So into Excel, they are going to type equals PMT. Let me break this off. And it's PMT because they're trying to find their monthly payment, right? First, we start with our rate, APR divided by 12, because you want it to become a monthly rate, comma. Well, how many payments are they making? 12 payments a year times 30 years in the loan. And the last one in, how much are they borrowing? Well, they're borrowing $100,300. Now notice there's a negative sign in front of that because they're borrowing that money. And notice I did not use a comma. If you type that into Excel exactly like you see it, it's going to spit out $464.50. So based off of this information, Beth and Joe will have to pay $464.50 a month for this house based on this given information. All right, let's go to number 6. Madison has decided to buy her first car. Go, Madison. It's your birthday. So she has saved $2,300 to use as a down payment, and she's pre-qualified for a 3.6% loan for 60 months. So that tells you how many payments she's going to make, 60. How much will Madison borrow if she finds a used Jeep for $13,995? Well, if she finds it for $13,995, don't forget she's putting $2,300 down. So she's going to borrow $11,695. So when she goes to Excel, again, she's trying to find her monthly payment. So her APR. Now, APR is 3.6%. We got to divide that by 12. Now, we know she's going to make 60 payments because that's how many months she's dealing with here. And she's borrowing $11,695. When you type that into Excel, it's going to come out $213.28. So there is the monthly payment that she's going to make. How much will she pay back over the lifetime of this loan? Well, think about this rationally. She's paying $213.28 every month, and she's going to do that for 60 months. So the total there is $12,796.80. So how much of her payments actually go towards interest? Well, if she paid back a total of $1296.80, how much did she borrow? She borrowed $11,695. That means her total interest is $1,101.80. This is how much she's paying in total in interest over those 60 months. So if you wanted to figure out how much each payment goes to interest, you would take that value and divide it by 60, which I did not do on my paper. So 1101.80 divided by 60, $18.36 a payment went towards interest, in case you cared. All right, let's talk about Mabel. Mabel's attempting to purchase a new home, but she wants to know which of the loan terms her bank is offering would be a better option. She's been offered a 15-year loan at a rate of 3.25% or a 30-year loan at a rate of 4.5%. She's going to have to borrow $69,800 after her down payment. Okay, so we've got two different problems here. So we'll do the first one in burgundy, 15 years. She's trying to find her monthly payment. So we're using PMT. Her first one is at 3.25%. Don't forget to divide your APR by 12. It's only 15 years, so 12 times 15, and remember she's borrowing $69,800. The second one, which we'll note in blue, is a slightly higher interest rate. Again, we divide by 12, and this one is for 30 years, borrowing the same amount of money. Now, in the red one, it comes out for the monthly payment of $490.46 per month. For the blue one, per month is $353.67. So, you might look at it and say, well, obviously you do the blue one because it's cheaper. Well, depends on what kind of pickle you're in at this very moment. If you can't afford $490, well then yeah, your only option is blue. But let's look long run, okay? So remember this one, for the red, you're doing this 12 months a year times 15 years. So the total payback for that one is going to be $88,282.80, right? That's the total payback. Well, the second one, you're doing this 12 months a year for 30 years. Your total payback is $127,321.20. Look at that. That's like an extra $40,000 you're spending. So, yeah, it's cheaper per month by, $137. No, yeah, $137. But over the course of the loan, you're going to pay an extra $40,000. So if you can afford to pay $490 a month, you really should do the 15-year because you're going to pay less in interest over the life of your loan. Right? You're almost buying two houses doing it 30 years, whereas the 15 years, you just straight up, you pay less in interest. Number 8, Haley doesn't know what sort of car she wants, but she knows that she can only afford to pay $250 a month. Okay, so now she knows her monthly payment. The first lender she speaks with qualifies her for a 3.6% loan for 60 months. What will she put into Excel to see how much she can borrow? All right, well, let's look at this. So she's looking for the present value of her item. We know her interest rate is 0.036. Again, divided by 12 because we want it to be a monthly interest rate. 60 months. So she's going to make 60 payments, and she can afford to pay $250 a month. When you do that, she can get a loan for $13,708.72. So she should not be looking at $25,000 cars. She should be looking at $13,000 cars or less, right? Because don't forget, you're going to have to pay taxes and title and all that fun stuff. Now let's go part B. Haley talks to a different lender. She qualifies her for a loan for 72 months at 4.25%. What kind of cars could she get if she did this one? Well, okay, same concept. You're looking at present value. We take our interest rate, 0.0425, and we divide that by 12. This one is 72 months, so you're making 12 extra payments. But don't forget, she's only paying $250 a month. When she does that, she can afford a $15,863.60. Now, she's going to pay more over the life of that loan because it's a little bit higher interest, and I think that's actually the next question. But let's look at this. How much will Haley pay back over the lifetime of each loan? Okay, well, when you look at the first one, she's paying $250, but she was only paying 60 months. So she was going to pay back $1,500. And recall that she borrowed $13,708.72, right? That was this problem here. So if she borrowed that amount, but she paid back $15,000, I'm going to just write down here for a little bit. Her interest was $1,291.28. Okay, so that's interest. Now the other one, she paid $250, but she paid it back for 72 months, so she paid a total of $1,800. That one, let's subtract the $15,863.60. She paid $2,136.40 in interest. So you can see she paid, over $900 more in interest by going with the 72-month loan rather than the 60-month loan. Yeah, she got a little bit more money for a car, but at the same time, she is going to end up paying back more money. Okay, part D. If Haley finds a used Camry for $14,000, is either loan an option for her? Yeah. If you recall, the second loan here, she could use $15,000 some. So she wouldn't even need that whole loan amount, but she could totally use the second 72-month loan and buy that used Camry for $14,000. All right, let's go to Noelle. I think this is the last, multi-step problem. Noelle makes $15,000 annually. She actually earns $50,000 annually, and she wants to know what size of a mortgage she can afford as she plans to move in the next 6 months. She expects to pay property taxes of around $650 a year, and her homeowner's insurance will cost about $850 a year. She has a $300 car payment and makes a $100 credit card payment each month. What do we need to know first before we can use a formula in Excel? Well, we need to know, if she's trying to figure out the size of a mortgage, she's trying to find present value, which means we need to find out the monthly payment. We also need an interest rate and how many years, number of years, but we'll get to that. The big thing is we got to figure out her monthly payment. Okay, so we are going to use the total expense ratio to figure out what she can afford. So if you recall this, approximately 36% of your gross monthly income. Now, Noelle earns $50,000 a year. Well, that's a year. If we divide it by 12, that gives us her gross monthly income. And that right there is approximately $1,500. So that's kind of the upper end of what she can afford. And then we take out the things that she pays. So remember, she said she's got insurance and property taxes at $650 and $850 per year. So when I add those together and then I divide by 12, we've got to take away $125 because of taxes and insurance. And then don't forget, we also have, she's got a car payment and a credit card payment we need to take into account. So we're going to subtract another $400. So maximum, she can pay $975 a month. And I'm saying if you figure that's out, you really don't want to get close to that. What if something happens? What if you get sick? What if your water heater goes out and you got to buy a new one? There's just so many different expenses that go with buying a house. You don't want to become house poor and have all your money going to the house payment. So just be aware of that. But $975 is her upper end. So she's qualifying for a 15-year loan at 3.25%. How much of a mortgage can she afford? So here is where we use our present value. We've got our interest rate. We divide it by 12. 12 months in a year, 15 years in the loan, and as we just found out, she can afford a $975 payment. So therefore, that leads to a $138,756.70. That's the amount of a mortgage she can afford. Now, that's if she goes 15 years at 3.25. What if she says, you know what, I really want a 30-year mortgage because it'll make my payments less? Well, or I can buy a bigger house if she's going to keep the $975 payment. So present value, we're keeping it, our interest rate is 4.5% divided by 12. Now we're doing 30 years in the mortgage. She's going to keep her $975 payment. That allows her to buy a house up to $192,427.13. Again, I would be very hesitant to buy a house on the upper end of your budget, just because that really puts you in a financial bind if anything happens where you need extra money. But that is loans.